basically what we're doing is just working more with operations on polynomials. But the polynomials contain multiple variables, so they're kind of like a regular expression. So what you want to do is use that same strategy where you're combining like terms. Okay? So let's do some examples here. And they put them in parentheses. So we'll go x squared y minus 2xy plus 8 xy squared x squared y minus 5xy plus okay, so there it is, something like that. All right, so all we're going to do is combine like terms again. All right, but we just got to look at the powers to figure out which ones are like. Okay, so for example here we have a 4x squared y and a 3x squared y. Those are like because they have the same exponent and the same power on the variable, so they're alike. So we'll combine those, and it's a plus, so we're just going to add them. Then we have an xy and an xy, so we're going to combine those. And again, we're adding them. They're both negative, so it's okay to do that. I'm getting a bunch of 7s. Let's see, then we got xy squared, 12xy squared. Those are like. I'm going to add them. And when I was saying last week, well, you want to make sure you're kind of writing things in decreasing order. In this case, there's no degree, okay? Because it's combining variables, so there really isn't a degree to this, so you just kind of write it out in a way that, well, I guess it's kind of however the order came about, it's the best way to write it. Okay, so we're just combining like terms like you were doing before. So let's try one that's a minus here. And we'll put a minus in there. Okay, so then I have one like this now. So I'm going to combine those like terms again. I'm going to start with this one. And here I see again the same powers. Okay, so, but we're subtracting. So I think what I said last week is that you can take this minus and move it inside to each one if that's how you think it's easier for you to do it, or you can just read it and do it. So it doesn't matter if you want to move this inside, then we'd have a minus 5x4y squared minus 3x squared y minus y squared. However, which way you want to do it, it doesn't matter to me. I just want you to get it right. So I'm going to combine this one and this one. Going to give me a negative 2x to the, I wanted it in red here. Negative 2x to the 4th y squared. Okay, then we have here and here. Okay. So 5 minus 3 is a 2 x squared y. And then here, I don't have a y, just a y. I have a y squared. So I really can't do anything with that one. So I'm just going to drop it down here. And finally, I have this one, okay, which is a minus y squared. So I'm just going to drop it down. All right. So that's done. So I can't do anything else with it. That's the answer. So again, all we're doing is combining the like terms, looking for those common powers on the terms. So, and I would say that when you're taking your test on Thursday, make sure you're not going to have one like this with all of these extra variables and multiply it. So I would make sure that you're reading it slowly, take your time. If it says minus, you're going to subtract. If it says add, you're going to add them. I just don't see how we would have one, we would 401 like that, okay, because it's really messy. So if you start multiplying, you're getting these crazy powers, you might want to go back and look at it and say maybe this is an addition or a subtraction between those parentheses. Okay. And we'll get a couple, I'll give you a couple of those to practice too, but I don't really see, I mean, it's pretty much the same as last week. Here's some other ones. I don't know why I just did that. So now we're just going to kind of distribute. Okay, so we got here and here. So we're multiplying now, so then we're going to take 3 and 2, multiply x. What would the power be on the x? We have x times x, so that's going to be x to what power? Squared, very good. Okay, the y doesn't have anything here, so it's just going to stay as y. All right, nothing, there's nothing to multiply the y with. Now I'm going to go over here. Again, I have nothing to multiply the x, so that's x, and it's going to be y to what power? Second, yep. Okay. Now you would think, hey, maybe I can combine those, but can we combine those things? Are they like? No, they're not, because that's x to the second y and an xy to the second. They're not like, so we can't combine them. That's it. That problem's done. So make sure you're careful with what you combine. Let's see here, they have one with an AB in it. Okay, so let's work through this one. We're distributing. All right, so let's try this one out. So 3 and 7 is 21. Come on. What? Oh, you're getting it and I'm not. Okay. I've been down this path. All right. I have no idea what's going to write it. All right, down here. This is a lot harder than what it looks. Okay, so I got 21a to what power? 3, good. And b to what power? 4, good. Minus 12, a to what power? Second, good. B to the 3. Can we combine those? Can these things be combined? No, because, I don't know why I did that. No, because this is a 3, 4, and that's a 2, 3, so no, can't be combined. All right. There are some foiling ones. Oops. I'll show you some of these here. 3. Times plus 5. Okay, so now we're going to do this one. Alright, so now we're just going to FOIL this here to here. From here to here and from here to there. Okay, so first times first, that's going to give us 6a to what power would that be? Second. And b to the second. Good. Alright, now we're taking the 3ab times the 5, so that's going to be plus. Sorry, that's a plus. It doesn't look like it, does it? Plus. Okay, 15 AB, because there's no ABs to worry about, minus 8 AB. Okay, and then minus 20 okay, so now we just got to combine the like terms, and when you FOIL, almost every time stuff in the middle is going to combine up. So let's see, we got 6a squared b squared. Okay, then we have all this stuff here in the middle is going to combine. Plus 7ab minus 20. Alright, so again, it doesn't, when you're FOILing, you just kind of just go with those, with your exponents and add them and combine them and like that. So there really isn't anything in there that's anything different than what we were doing last week, conceptual. It's just they're throwing some extra variables in there. Okay. Any questions on that? Okay, I'm going to do a little bit of 5.5, and then I'm going to have to shut this down and reboot so I can see what the heck I'm doing better. Okay, so last week we did some properties of exponents. Okay, and I know that one of the first properties that we did, we had a to the m times, and you don't have to rewrite this because you've already did it. And then we had one that was like a to the m. I don't think I'm doing in the order I gave them. N equals a to the m times n. And then we had one at a to the m. I think we did this one. A to the n equals a to the m minus n. Did we do that one last week? Does anybody know that? You don't remember that one? No, it's not. Everything I did last week. Let's see if we can find it. No, we did those ones. Okay. come on. There we go. Okay. So let me go back here and show you where this comes from then. All right. So where this comes from, this last one that we did here, is if we have x to the 5 over x to the 3rd. Okay, so that's equal to x, x, x. Oh my goodness. Sorry. X, x, come on. X and x. Over x, come on, x and x. Okay, so what happens is that these x's cancel out and leave me with 2 on the top. Okay? So conceptually, on the properties of exponents, what we do is we just subtract these because we're canceling out, so we're just going to subtract and get the difference. All right? So that's where that other property comes from right here. So we're going to subtract. So when we multiply, we added the exponents, and we divide, we're going to subtract the exponents. That's basically what's happening. All right, so let's try down here. I'll give you a couple examples, and then I'm going to reboot this darn thing. So if I have a to the 6th over a to the 2nd, then I can think of this as 6 up here and 2 down here. So 2 are going to cancel, leave me with 4, or I can just subtract, get a to the 4th. All right. Same thing can happen if we have an a to the 3rd here and an a to the 9th here. Okay. Then I have 3 a's up here, 9 down here. 3 are going to cancel. I'm going to get a 1 though on the top, so I need something to show for my top, and then 6 on the bottom. All right. Because 9 minus 3 gives me 6. So that's that property of exponents. So whenever you're dividing, you're just subtracting the exponents then. So they give you some problems on that in the beginning. And then the other property that they show you here is taking something to the 0 power. And anything to the 0 power is always going to be 1. It doesn't matter what it is, it's always going to be 1. So even if we have like 3x to the 5th and all this is to the 0 power, it's going to be 1. Okay? So anything to the 0 power is 1. Doesn't matter what it is. So you should add that one to your property of exponents too. Any questions on those little new properties there? Okay, we'll do some more stuff from 5.5, but since I can't see what I'm doing, I have to reboot this whole thing or else it won't work. So why don't you go ahead and we'll take a little break here. I'm going to pause this. Actually, I have to save it.